How are drones fighting fires without human pilots? Stop thinking that a firefighting drone is just a flying camera, connected to a human pilot with a joystick, because in a blinding, completely smoke-filled high-rise building, human eyes and human reaction times are absolutely useless. Most people assume that a drone operator just stands safely outside, staring at a little monitor and trying to carefully steer through the flames. But think about the physics of that environment. The second you fly into toxic black smoke, you lose line of sight. Your radio signals get scrambled by the dense carbon, and extreme thermal updrafts throw the aircraft out of balance. A human pilot's brain simply cannot process that level of aerodynamic chaos fast enough, which usually results in the drone crashing into a wall within seconds. To actually survive and fight in that environment, we have to completely remove the human from the flight loop. This is where the absolute bleeding edge of electronics and communication engineering merges with fire technology. An autonomous firefighting drone doesn't rely on standard optical cameras that get blinded by smoke. Instead, it uses a complex, real-time sensor fusion of high-resolution thermal imaging and LiDAR rays. As this machine flies into a burning warehouse, its onboard microcontrollers and machine learning processors are crunching millions of spatial data points. It uses a technology called Simultaneous Localization and Mapping to instantly build a 3D digital wireframe of the room. The computer vision algorithms are trained to instantly differentiate between a collapsing steel beam, a highly explosive chemical drum, and a trapped human victim, all in pitch darkness. It reads the thermal gradients in the smoke to calculate the flow paths, actively predicting where the fire is pulling its oxygen from, so it can safely navigate the deadly thermal currents. But the true engineering miracle is that it doesn't just watch the fire, it actually executes the kill chain autonomously. Once the artificial intelligence identifies the highest, most intense thermal signature, the exact seat of the fire, it calculates the precise mathematical trajectory required to neutralize it. This is exactly where hybrid heavy-lift drone models change the game. Instead of trying to carry hundreds of pounds of water, the AI automatically maneuvers the hexacopter into the optimal drop zone, adjusts for the violent thermal updraft, and precisely drops a payload of heat-activated fire extinguisher balls. The moment these chemical spheres hit the extreme heat, they burst, releasing a massive cloud of dry chemical powder that instantly suffocates the flames, without a single drop of water, and without putting a single human firefighter at risk. We are taking the heavy, physical labor of firefighting and replacing it with autonomous, high-speed robotic precision. Whether your goal is to command these automated squadrons from the ground, or engineer the flight systems, the future of emergency response is entirely robotic. Stop relying on slow human reaction times, start engineering the autonomous swarm, and make sure to subscribe to Decode to master the AI revolution in fire safety.